Hi, we are the mixed team of the Technical University of Chemnitz and the Technical University of Darmstadt and took part in the Data Mining Cup competition 2020 and would like to present our approach of solving this task. Our team consists of 5 members, where 4 of us are taking part in the master degree program Data Science at the TU Chemnitz and 1 is studying Industrial Engineering at the TU Darmstadt. We split up our team into a feature engineering group and a modeling group, where the feature engineering group tried to detect the promotions properly and also create more and more features for our models, while the modeling group was in charge of doing some research and then implementing promising models. We think that the most challenging part of this year's competition was how to detect the promotions. And at the beginning, we tried out some spike detection algorithms, but it didn't work that well. So we asked ourselves if we somehow can gain more insights. And therefore, we had a look at the partners of prudsys, and we were trying to find an online shop that has the following properties. So that they have like 8 different main categories, and in these categories, the number of items should be distributed like we see it here, and so on and so on. We were actually able to identify the company where the data comes from, and it is a teleshopping company, which made perfectly sense because their business model heavily depends on promotions. So what we did is that we watched some teleshopping for quite some time, and we figured out that a promotion always begins with a start price, and after a while the price decreases until the promotion has ended. And if the promotion has ended, every customer pays the same price, which means that the company has to wait until the promotion has ended to fulfill and to complete all orders. And that's what we were looking for in the data. We came up with the idea that whenever an item is promoted, the orders should be in a minimal time shift. We decided to go with the rule that a promotion is a promotion if 2 orders of the same item are in a time shift of 1 second or less. And this is how we detected the promotions. So during the exploration phase, we observed that the transaction IDs are actually ordered in an ascending way over time, but somehow there are some transaction IDs with a very high number that are in between these transactions. And at first we were not sure what this is, but with our domain knowledge, we think that these are probably online orders, and we filtered them out before we applied our rule of how to detect the promotions. Here you can see the promotions that we detected during the training period of 180 days. And for the simulation period, the promotions were given. And especially here at the end, you can see that our number of daily detected promotions is quite similar to the promotions in the simulation period. However, at the beginning, we didn't detect that many promotions, but if you had a look at the orders CSV file, you were also able to see like a linear trend. And that's why we think that our promotions are quite okay. Of course, they are not perfect, but we suppose that we have a low bias, which is pretty good for predicting the simulation period. Although we were quite happy with our promotions that we detected, we were seeking for a way to validate them. And what we did is that we had a look at Web Archive, and we were able to find for 2 given dates in the training period the TV program. And usually it is the way that for 1 given hour, just 1 category is promoted. And what you can see here is that we were trying to see if our detected promotions match with the real promotions. And in this case, we detected for this hour, for the hour 744, 5 promotions in category 8 and 1 promotion in category 2. And also for other hours, we saw that it works quite well. And this made us confident that our approach of detecting the promotions works good. So the rest of the time we created a lot of features, nearly 60 features in total, and we used forward stepwise selection to select the most important features of our models. We figured out that like 10 to 20 features were quite good. And we also applied some hyperparameter tuning, in which we first defined some promising hyperparameter spaces and then used cores and fine randomized search to get the best hyperparameters. We tried out 6 different regression models and used time series cross-validation with the following cost function, namely that we wanted to maximize the predicted return over the maximal return that is possible given the matrix in the task. In the end, we decided to go with the voting approach, which means that we just took the mean of the best models, which were an XGBoost and a random forest. And for the given cost function and for 5 folds, we had a score of 48% in the end.